check. Okay. All right. Let me check my audio real quick while I'm on this scene. Make sure the beat and my voice are coming through. And let me check that real quick. Looks like the beat isn't coming through. Hold up, let's see here. That's weird. Audio. Let's see. Beat. Yeah, it doesn't really matter. Let me, I'll just pull it up on QuickTime or something. Oh, you can hear it? What? Oh, it just came through. Okay. Yeah, I was monitoring on YouTube and I'm behind like 30 seconds. Okay. Yeah, Streamlabs has given me a lot of issues with audio. All right. Okay, so I am going to go through how to set up a new JUCE project, kind of the basic architecture of a JUCE project, how to, what the methods are, kind of like the order of operations, and then do some audio processing. So let's see here. I'm going to open up the producer and I'm going to hit new project. And whenever you download the JUCE repo, I'll show you here. It's easier just to clone the JUCE repo. That way, whenever there are updates, you can just pull changes like a normal repo. And to get the producer, where's JUCE? Let's see here. Okay, so you go into, let's see, examples. No. Yeah, okay, so you go into extras, producer, and then you would open up this project in Xcode or Visual Studio, whatever, and then you'll build it, and then that will give you the producer, which is this piece of software right here, which is just like a project management, like a project creator for JUCE. So it'll auto generate all the files you need for Xcode or Visual Studio or whatever. And for everything pretty much I do, I use this basic plugin format. Everything else, audio, is going to be a GUI application, like a standalone application that you can do audio. GUI is going to be like a standalone application that's just like GUI. You could do a console, which I do sometimes to test C++ stuff, but I'm going to do basic. And then what should I call this? Stream, I don't know. Stream JUCE intro. And I always add the DSP module just because you never know whenever I'm gonna, want to use it, which is really cool. And then if you pull in my library, it relies on the JUCE DSP module. So let's see. Okay, I'm gonna create a repo for this. So I'm gonna go to GitHub Desktop. I'm gonna cancel that real quick. Let's see. GitHub Desktop, and I'm gonna say new repo. It's hard to type with this microphone in front of me. Let's see, stream JUCE intro. I'm gonna get a README. I'm just gonna do a C++ git ignore and license. I don't know. I don't really care. Let's do GNU. That cool. Now we can go back to the producer and go back. Let's see. So it says stream JUCE intro. Cool. So now I'm gonna put it in that repo. Boom. Okay, cool. So now a couple of things you want to do is open up this project settings. So this is all the metadata that's going to be associated with the build and the project and stuff. So if you don't put anything in this company name right here, your plugin by default in your DAW will be under something called your company, which you don't really want. So I'm going to say Viator DSP. And after you do that, if I scroll down, you can see this bundle identifier now has Viator DSP. And then you can choose your plugin formats. I usually just do AU and VST3. And then you come down here, plugin manufacturer. Since we typed in Viator DSP, it puts that into here. And then your plugin name, this is what you're gonna see in the DAW on the drop-down list. So maybe, I don't know. I'm just gonna leave it like that for now. And then not too much other stuff that I change. We could change the C++ 17 if we want. And then, cool. All right. Then I want to make also a Visual Studio exporter so that you can use the same project and build it in Xcode or Visual Studio. I kind of forgot. Let's see. There's yeah, so go down to this plus button and just say Visual Studio 2019. So now you have a cross-platform project that you can open on Mac or Windows and build whichever one you need. And let me double check. I got Viator DSP, I got the name, whatever. All right, cool. All right, it opens it up in Xcode for us. I'm gonna close all of this stuff right here, open up the 4 source files that JUCE gives you. And before I even go through any of this, I'm just gonna build. So in Xcode, and Visual Studio is pretty similar, except in Visual Studio, you'll change the build. It's gonna be over here on the right. But in Xcode, it's up here. So we can change to build just an AU version or just VST3. We can do standalone. I'm gonna do standalone first. It's really helpful for just checking things really quickly, checking things visually. So since I'm on M1, I'm gonna actually have to do Rosetta. But if you don't have an M1 machine, you'll just, I think there'll just be one choice. It'll just say My Mac or whatever. So yeah, standalone. And for standalone, you can just hit the play button. And it'll take a little bit of time. It'll compile it for the first time. The first build always takes forever, and then all the other builds after that are much quicker. So it just built successfully, and it is going to open up the standalone version of the plugin. And the standalone version doesn't do any audio. It'll just basically be a way to look at the UI. Okay, cool. So this is what the plugin looks like by default. The first time you build it, it just says hello world, you know, typical programming stuff. And this is what it would look like in the DAW also, but we just opened it as a standalone. So that's how quick and easy it is to check things. So without even explaining too much, I'm going to change the text just so that you see how quick and easy this is. So I'm going to go into the plugin editor and change this to JUCE stream. And if we hit play, it'll build it. It'll open it up. And we can see our change. It says JUCE stream. So that's how easy it is whenever you're prototyping UI to just build in standalone. And then we can build it as a regular plugin. I could do all, but I'm just going to do AU because I check everything in Logic anyway. So now it's under AU, and instead of hitting the play button, I'm going to hit build. Cool, it built, and I'm going to open Logic and see if it's in there. Now on Windows, I don't think the build will automatically get sent to your VST folder. You'll have to actually manually put it in there, but on Mac, it puts it in there for you. So I'm going to do a new file, audio, and I'm going to say intro. And let's see if our plugin is there. Let's see, I'm going to go down to audio units, Viator DSP, and I already forgot what I called it. Oh, stream JUCE intro right here. And boom, look at that, JUCE stream. We got our plugin. It's in Logic. Look how easy that was. We have a plugin. It says my name, and it's really cool. I'm not going to lie. Okay, so there is a way to build and test in Logic by attaching it to Logic also. So if we go up to product, we can go to scheme, edit scheme. And for the build configuration, you can build as debug or as release, and release is the build that you're actually going to release to the public, because when you build in release mode, it gets rid of all of the debug things that Xcode will do for you, and it'll optimize all of the code. So while you're in debug, you can check debug statements like assertions and things like that. And the really cool thing is you can use Logic to open the plugin in debug, so that if your plugin crashes for some reason and this is attached to Logic, it'll actually take you to the part of the code that crashed Logic. So if we go to this executable, we can go to other, we can type in Logic Pro. Cool. And then, like I said, I'm not going to explain all of these right just this second, but I will do something to kind of show you what I mean real quick. So what I'm going to do is I'm going to make a random variable here. I'm going to say bool debug, I guess, is equal to false. And then I'm going to do something called an assertion, and JUCE has its own kind of wrapper around assertions called jassert. I don't remember if I have to use the JUCE namespace or not, but I'm going to just do jassert debug. So what this is going to do is it's going to give you an assertion if whatever you put in equates to false. And it did. So watch this. We're going to attach to Logic, since we've done this product scheme edit scheme. Now you can see the little Logic symbol is next to our plugin, and now we can click the play button. It'll build it and open it attached to Logic, and Logic will open for us. You can see it opening at the bottom right here. And we should hit this assertion. Okay, so let's open Juice Stream intro. Okay, and let's pull the plugin in. And we hit an assertion. Check this out. So what we've done is, since we're building the plugin in debug mode, we have this option to use assertions and other debug commands in Xcode. So what we've done is I've created like this fake assertion or this fake issue. So what we've done is, since we're attached to logic, it brought us to the line of code that asserted basically and gave us this assertion. So this is really handy for if you're working. One example is whenever you're doing UI stuff, if you don't clean up memory related to Juice's look and feel class, you'll hit an assertion in the Juice library, and it's kind of like a reminder to go, hey, go to this line right here and make sure that this isn't actually a problem. And this is super useful, and I wanted to bring it up before we do everything else, because for the longest time I didn't know this was an option to, I didn't really know how to use Xcode that well. I didn't know how to attach processes and stuff like that. So for a long time I was developing without this, and it really is something that you shouldn't overlook even when you're just learning. So I would say set up your project the way I did, where you go to product, scheme, edit scheme, and you can choose which DAW you want to open it with. Like I could do Studio One or Reaper if I wanted, but I do everything in Logic. I like Logic. So that way you have the option to open it in debug mode with Logic. And basically you can build it in 3 different ways now. You can go to standalone right here if you just want to check the GUI real quick, check the way the plugin looks. Cool. You can go back to AU, and if you want to open it with Logic opening at the same time, you can hit the play button. But if you don't want to do that for some reason and you just want to build it, you can go to product, build, and it will build and not open Logic. It'll only open with Logic if you hit the play button. So all of this is super necessary and super helpful. Cool. So now we've done that, let's check out kind of the source files that Juice gives you. So by default, you have all the library code associated with the Juice framework. And because it's a framework, it's basically just a bunch of code that a bunch of really smart people wrote that makes it easier for developers like us to use the framework and write a higher level kind of, or interact with the framework at a high level, like by just calling things like, audio.process or slider.setColor. Whereas the framework has all of the low-level implementations of how to make those things actually do something, right? So Juice made it really easy for us. They're already capturing audio from the DAW for us. They're already doing all of these interactions with audio that we don't have to do, that we can just write DSP and do some cool stuff. So basically, we have 4 files that Juice gives us by default to work with: the plugin processor and the plugin editor. Now, the plugin editor is all of the GUI based stuff. So that's like, the UI stuff like that. And then the plugin processor is all of the audio based stuff. So audio processing, your audio parameters that you can, your automatable parameters. So it also has all of the parameters that you'd be able to see in your automation data in the DAW. And each one gets a header and a CPP file. Now, if you're coming from like, JavaScript or something like that, usually there's one file type. It's just like, a JS file or JSX, whatever you're doing. And C++ has 2 file types, basically header and CPP. And a lot of times there's a lot of under the hood stuff that's different about CPP files and header files. But the way we interact with them, kind of just, you use the header to kind of define your variables and your functions to say what they are. So like, for example, we've got void Git State information, and you can see that we don't have brackets like this, you know, with code inside of it. We just have the definition of it. So in the CPP, we'll have the actual implementation. So if we look for Git State information, if we go into the CPP, we scroll, I know where it is, but we scroll down, Git State, and this is the actual implementation. And this is an override function, right? So that means we can override it and put our own code in it. But yeah, so this is the actual implementation. That's where the code goes. And this is where you would actually store your parameters in memory. So let's go through all of the super important methods in the plugin processor. So up here, just like any other programming language, or I mean, I don't know about every single one, but we have the constructor. So right here, you can see we have the class name, which is stream juice intro, and then this implementation right here, which makes it the constructor. So we can put some stuff. For example, if I make a variable called float gain, and I don't initialize it, I could come up to the constructor, put a comma, I should be able to say gain, and it'll ask me what I want to set it to, and I could say 22 or whatever. So this is a normal constructor. You could use it this way if you wanted, or you could simply, you know, just set the value to what you wanted right here, which is perfectly fine. Doesn't really matter, especially when you're starting out. So that's the constructor. We have the destructor, and this is called whenever this is the destructor, and it's called whenever the program shuts down. So you can use that to clean up any possible memory leaks, stuff like that. Let's see, get name. We can kind of ignore some of these. Some of these I don't really touch at all. If we scroll down, we'll get to the next super important one, which is prepare to play. So this function is called, it is guaranteed to be called before audio playback, and this happens in the DAW. So you can use this to do anything that you would need, any kind of processing or checks before audio starts playing. So channel configuration, set up your sample rate, stuff like that. Now, you're guaranteed for this to call before audio playback, but you're not guaranteed a certain time or in a certain order with other methods. So you can use this to do any pre-playback stuff, but you can't always rely on it to, for example, we have another method, set state, which whenever you have a plugin that you've already saved, like say I opened Logic and I had my plugin open and I changed some parameters on the plugin, I saved it and I shut down. Whenever I open Logic again and my plugin comes up, this set state information pops up, and it'll do whatever is in here. But you're not guaranteed that set state information, or at least I don't think that set state information is going to happen before or after prepare to play. So anything that relies on certain order, you probably shouldn't assume that it's going to happen in one of these methods. So like if you want to set the your saved parameters to a value, you'll probably want to do it in both the prepare to play and the set state information, just to make sure that, you know, if your prepare to play has some kind of check on the parameters, you want to make sure that they actually exist. So if prepare to play happened first and you were relying on something that set state sets, you're probably going to have an issue. So that's kind of a long ramble about something that might not necessarily be as important at the beginning, but it is something to think about. So we've got prepare to play. This is going to happen before audio playback. And then kind of on the other side of that coin, we've got release resources. Whenever playback stops, this is going to be called. So you can do anything like, you know, any kind of reset, filter reset, stuff like that. We've got, let me skip the process block real quick and go down to Git State and set state. So Git State, this gets called whenever you save data in the DAW. So like if you have your DAW open and your plugin open, you change some parameters and you hit Command S to save. This will get called. So this is when you should save the parameters of your plugin. And then, like I said, whenever you open up the plugin again, set state gets called. So this is where you're gonna get the saved parameters and then set them up into the plugin so that it recalls the values and has the correct values. And lastly, the most important part, the process block. This is where you have the audio buffer that's coming in from the DAW, or the samples that are coming in from the DAW into this buffer. And you also have this Midi buffer. I don't really do any Midi stuff. I've done one synth, tutorial following on the audio programmers tutorials, but I don't know. I'm just not as interested in it as I am with audio, so I don't ever really use the Midi buffer. But the audio buffer is definitely the important part. So what's happening in the process block? This is a continuous loop that's being called during playback, and even whenever playback isn't happening, sometimes in some certain circumstances. But what's happening is the process block is pulling in samples from the DAW in block sizes. So you know how in your DAW you can choose a buffer size of 32, 64, 128, 256, 1024. Whatever that's set to in the DAW is going to be the maximum size that this process block takes in and processes on. So one way to think about this is, how often is this process block being called? And this process block is not being called. Let me back up a second. You might think that if the sample rate is 44,100, that this process block is being called 44,100 times a second, but it's actually being called sample rate divided by block size times per second. So if our sample rate's 44,100 and our buffer size is 128, it's getting called 344 times. I'm not 100% positive what happens whenever it's a decimal or a float value. I assume it's just going to be called 344 times, but I'm not 100% sure. So this process block is being called that many times, and this is where you have access to the buffer and you can do processing. So we can read these comments. I always delete these comments, but if this is the first time you're looking at this, it's probably a good idea to go through it. So this block of comments right here, you know what? I need to do this in a way that if you're a very beginner programmer, that you can understand this. Okay, so comments are basically just text that you can write in your code that doesn't get compiled and has nothing to do with the actual execution of the program. It's just a way for programmers to make notes, basically. So these comments are describing this for loop right here. And a for loop is just a way to execute a method multiple times, or execute a block of code multiple times. So what is this saying? So this is taking in total number of input channels, and we're looping through however many there are. And I think most of the time there's like 2, right? So this loop is going to happen 2 times, and we can see that we have this word clear right here. And even if you're not sure about, even if you're a beginner and you're like, I have no idea what this line means, we can see this word clear and we can just assume, okay, the buffer is being cleared, whatever. So let's read these comments. In case we have more outputs than inputs, this code clears any output channel that didn't contain input data, because these aren't guaranteed to be empty. They may contain garbage. And we can see that where it says output channels right here, but it says input channels right here. So this is here to avoid people getting screaming feedback when they first compile a plugin, but obviously you don't need to keep this code if your algorithm always overwrites all the output channels. And in fact, I don't think I've ever removed this code before. I'll always just leave it in there. Let me get rid of the comments, clean that up a little bit. And you can see total number of input channels right here and total number of output channels right here is being referenced from right here. We've got input and output. Cool. So let's check out these comments, and let's check out this for loop real quick. So this for loop is looping through the number of channels. So you can see total number of input channels. So, you know, most of the time 2. So in our case, this is a stereo plugin. Or if you load it in on a mono track in your DAW, it'll be 1. So sometimes you kind of have to code for the possibility that you'll have 1 channel as opposed to 2. Sometimes it doesn't matter, but sometimes it does. And you know, we'll look at examples like that, but sometimes it's obvious, sometimes it's not, but you know, something to think about. So what is this saying? Let's go through a for loop right now, just in case you don't understand what a for loop is. So a for loop is going to execute a block of code a set number of times. And this line right here kind of tells you how many times. So what we're first doing is setting a local variable called channel, and we're setting that to 0. And then what we're saying is, we can skip this for a second right here. Every time the for loop executes, this variable channel gets incremented 1 time. So channel right here is 0. It executes the code, and then channel now becomes channel plus 1, which is 1. And this right here checks to make sure how many times we want to do this, and then stops the execution if we hit those number of times. So let's say this total num input channels is 2. If channel is less than 2, then we're going to execute the for loop body, and we're also going to increment. So whenever this is no longer less than 2, the for loop isn't going to be called anymore, and I just blanked out for a second. The for loop isn't going to be called anymore, and then we're just going to continue execution down this way. So that's kind of a long and drawn out way to say that this for loop is going to execute this code twice because there's 2 channels. Cool. So let's look at the comments. This is the place where you normally do the guts of your plugin's audio processing. That's definitely true. You're going to want to do that in the process block. You're not going to want to do that like in the prepare to play, which would be impossible anyway, but yeah. Make sure to reset the state if your inner loop is processing the samples and the outer loop is handling the channels. Alternatively, you can process the samples with the channels interleaved by keeping the same state. Now, that might be confusing when you're starting out, but I'll show you basically what we can do. Is right now we're doing this for loop twice, and we're looping through the channels. But what we can do is we can also loop through each set of samples in each channel. So if you kind of think about it as this for loop is being done twice, if we put any code right here, like I'm going to make a variable called number, int number is equal to 0, and then I'm going to say number is equal to 4, whatever. So what's going to happen is this for loop is going to process. It's going to create this variable called number, and then it's going to set number equal to 4, and it's going to do that twice, right? Once for each channel, basically, right? So we have 2 channels. The for loop is running once for each of those channels. So this is happening for each channel. And since that logic is the way it is, we can do another for loop for each channel and loop through the samples. So we can do kind of the same thing. This time we can call it sample is equal to 0. Sample less than, so we're not going to do total number input channels, right? We want all of the samples that are currently in the block of samples that's coming into the audio buffer. So that is actually pretty simple. Since we have access to this buffer variable right here, we can say buffer, and then we can get the total number of samples in that buffer. And here's a cool trick. If you don't know if something exists or what the possibilities are, just hit dot, and you can kind of just scroll through and see what all of the functions or the methods are for that class or that, you know, whatever it is. So How many are there? Not a lot. I'm just gonna scroll down and act like I don't know what it's called so that we can do this live time. Oh, here we go. Get num samples. There it is. So we're gonna do another for loop for however many samples there are in the buffer. And if the buffer size right now is 256, then this is gonna run 256 times, so once per sample. And then we have to do kind of the same thing, plus plus sample. Give it some curly braces so it's a block. And there we go. Right now, these two for loops are currently looping through every sample in each channel. So anything we put in this inner loop right here is going to apply to the buffer. So something real simple we could do, we have access to this called channel data, and we got this asterisk right here which makes it a pointer, and you can see that we're setting it to this right pointer of the buffer. And one thing to remember about the buffer is that there's two methods that are similar with this name right here. We've got get right pointer and get read pointer. And what I used to think was the read pointer is like the input and the right pointer is the output, but that's not actually what it is. The read pointer means that you can only read from it, you can't write to it. And the right pointer means you can read from it and you can write to it. Because what you're doing is you're not actually setting an input and output, you're just replacing what's in the buffer at any given time with other data. So it's kind of like doing this. We've got channel data right here. And oh wait, it didn't. So channel data. That should be the data that's in the buffer, right? But that's a pointer to the whole channel. So what we need to do is actually do some processing to just the current sample in time. And we could do that with these, with an open bracket. We could type in sample, and then we can set it equal to something, or we can actually multiply it by something. So what we'll do is times equals 2. And what this is doing is it's going to take the current sample that we're on and multiply it by 2. And if you're kind of wondering why am I not just saying sample? Like, why am I not just saying sample times 2? Wouldn't that multiply the sample by 2? Well, the issue is that sample is actually, remember, it's the index. It's the current count of how many times we've run the for loop. So sample is basically just an arbitrary number keeping track of where we are. So channel data is the actual data. So we need to say channel data and then give it a point in time, or give it which sample we want, which is always going to pretty much be the sample we're on. So sample. And now we're multiplying the actual sample data by 2. And what do you think multiplying your audio by 2 does? Makes it louder. So let's check and see if that actually works. We should be able to build this. I don't think there's any issues. Cool, that built. So let's go into logic, and we don't have any UI controls or sliders or anything. So what we're gonna have to do is basically just turn the plugin on and off and see if it makes the signal louder. So let's get that. Let's pull logic up. Well, let me check my multi-stream chat box just to make sure. Okay, cool. So I'm gonna pull in a loop. The loop I've been using for years to test things. Let me turn the beat off. And wait, I'm gonna sneeze. Okay, it went away. Let me make sure that the audio is working. So I turned the beat off. Let's see if the audio goes to. Yeah, it looks like it's loud though. Turn it down. That should be good. Okay, so here's a moment of truth. Let's put this plugin on. Okay, so currently we're at plus 6 dB. Okay, cool. Now we're back to normal. So it seems like it is making the sound louder. Cool. Look at that. It worked. We are some real DSP engineers right here. Okay, cool. So that is the basic idea of how to process audio in JUCE. If this was a little confusing, you might want to go watch a video about for loops. It's not difficult at all. We're basically just saying, hey, we're going to process some block of code, which is denoted by the open curlies, this amount of times. So basically, every time the for loop runs, our current count is going to increase. And if that current count is under whatever number we set, it's going to run that many times. So what we can actually do right now, since I know that the plugin is stereo, I can actually just change this to 2, and we could change buffer.getNum samples to 256 if we know that's what's coming in. And theoretically, that would work if that's what's happening in the DAW. But the problem is you could never know. Just because you have your DAW set to 256 doesn't mean that you're always going to have 256 samples. Every DAW does some weird stuff sometimes, especially, and it's not isolated to a certain DAW. I'm going to use FL Studio as an example, but it's not because FL Studio is bad or anything. But FL Studio is known to send, what is it? I think if you set your sample size to something, it'll send it sometimes. Like if you set it to 32, sometimes it'll send 18 and then 14 or something weird like that. But all DAWs do stuff like that. So that's why it's best to use the actual variable that, that JUCE pulled in, because we know that total num input channel should be fine because we're getting it from this get total number input channels, and we should know that get num samples is fine because we're getting it from the buffer. So we can at least be sure that those things are going to be correct, especially in a simple stereo example right now. Let's see, hold up, I had some. Oh, thanks for sharing my post on LinkedIn, by the way. Okay, let's do the same thing with a different concept. We don't always have to use the buffer. Oh, let me turn the beat back on. So we don't always have to use the buffer. We can also use an audio block, which is pretty helpful. So what I'm going to do is I have on my Stream Deck, I'm very lazy, so I have a lot of JUCE code pre-programmed in for me to press a button. So I'm going to make an audio block. So in the JUCE namespace and inside of the DSP namespace, we have this audio block, and an audio block is basically just an alias to the buffer. And you can see right here that I made an audio block. I called it block, and it's kind of referencing the buffer. Let's go to the docs real quick. Maybe there's something more I can explain that I was unaware of. We can go to the DSP right here, and we can go to audio block. Minimal and lightweight data structure, which contains a list of pointers to channels containing some kind of sample data. Okay, so basically the same thing as the buffer, but just in a different format. I'm not sure what the difference is really. Oh wait, here we got some more. This class doesn't own any of the data which it points to. It's simply a view into data that is owned elsewhere. You can construct one from raw data that you've allocated yourself, or give it a heap block to use, or give it an audio buffer, which you can refer to. But in all cases, the user is responsible for making sure the data doesn't get deleted while there's still an audio block using it. So this last statement right here, but in all cases, the user is responsible for making sure that the data doesn't get deleted while there is still an audio block using it. Now, you might be afraid of that statement, but while you're starting off and we're doing a very simple example, this is never going to be an issue. So we can do the same thing where we make 2 loops, but based off of the block instead of the buffer. So what we can do is, let's see. I'm not going to use the Stream Deck button. I'm going to actually write it out. Let's see. So we've got for int channel is equal to 0. So meaning we're going to start off with our count at 0. We're going to say channel less than, and then now we're going to use block dot get num channels, and then we're going to increment channel. Cool. Okay. So similar to this auto channel data, we need to do the same thing, but it looks a little different. And I'm going to try to remember what it is without looking it up. I'm going to call it channel data again. Block dot, it's called get array. Yeah, it's called get array of, wait. Wait a minute. Wait a minute. I thought it was called get array of right pointers. Wait, is it just channel pointer? Channel, okay. That makes sense, I guess. Block.get channel pointer, which is similar to get right pointer channel. And then we're gonna loop through the samples in each channel. So we'll say the same thing. Sorry. Int sample is equal to 0. Sample less than block instead of buffer. Get num samples. And then plus sample. And we'll do the same thing. We'll do channel data sample times equals, let's make it even louder, 4. So let's see if that builds and works. Okay, open up Logic. JUCE stream intro. Oh, I should have saved after I put this loop in there. In fact, I'm just gonna make it twice as long since the loop is already set that long. All right. Let me turn it down a bit. That's gonna be way too loud. Let me save. Okay, let's put in our plugin. Oh yeah. Seems to be working. Let's close that down. Cool, so that's the Audioblock version, and there's really not much of a difference between using the two. I always use the block only because, which something we're going to look at in the future, but the JUCE DSP namespace has a bunch of pre-made DSP modules for you. So let's look at chorus. So there's a chorus that you can just call and use. So where is it? Right here, process. So what you're going to do is you would make an instance of this chorus and you would call process on it. And there's this crazy looking thing, const process context ampersand context. So all this really means is you're going to pass in a process context, which is based off of the block. So you're going to pass in this process context and then pass in the block as an argument for that. And since all the DSP modules use that block as the context, I usually just make all of my stuff also use the block, just so that it's kind of similar to the way JUCE does it. You don't have to, like, it doesn't matter. You could do everything based off of the buffer if you want. It doesn't really matter. But yeah. Cool. So that's using the block. This is, I could have swore this was called get array of right pointers. I'm going to use my button and see what it spits out. Oh no, it says channel pointer. I don't know what I was thinking. Get array of write pointers. What? That must have been for something else. Cool. So we'll put some comments in here. My DSP block. And I'm gonna be a good little programmer. I'm gonna go to GitHub and you know what? We're just gonna call it initial commit. Push, publish, public. Cool. All right, let's do something fun. Oh, this is what we should do. So right now we're hard coding 4, right? We're multiplying the block or the buffer, the output. I'm dying. Hold on. We're multiplying it by 4. Wouldn't it be cool if we had a slider or something so that we didn't have to hard code it in? Now, what we could do is go into the editor, make a slider, go through all that nonsense, place it on the screen. You know, it would take like 10-15 minutes to do that. Something we could use is alternatively is an audio it's audio processor value tree state, I think is what it's called. I always forget the actual order of the words. Yeah, audio processor value tree state. Okay, so this kind of solves 2 problems for us. This is something we need anyway. This is what sets up having a tree state, or having this audio processor value tree state gives you the automatable parameters in the DAW. So if you don't use this tree state thing, you won't have any parameters in the DAW. But making this tree state thing gives you those parameters, but you can also use it to create a very quick generic GUI that you don't have to actually code any UI or visuals. So let's set up the tree state, which is something we need anyway. So we will say, let's see, I don't want to waste too much time, so I'm going to copy and paste from other projects, like this one. Okay, so right, we need a value tree object, so an actual instance of it. And for right now, I'm just going to make it public. Yeah, so it's a audio processor value tree state, and it's called tree state. Now, this doesn't have a default constructor, which means that if we just try to build right now, it'll give us an error saying that, well, the error say, will it just say no default constructor? Right. So constructor for tree state must be initialized because it doesn't have a default one. Now, a default constructor would be something like, I go to DSP, chorus right here. So this is the constructor. You can see how there's no arguments or anything in it, which means that it's a default constructor. But some other things like the oversampler doesn't have a default constructor. It has a constructor that you have to pass some information in. And that's the same thing as the tree state. So what we could do, we can actually do this 2 different ways. It doesn't really matter. We can go into the constructor initializer list right here, and we could say tree state. And yes. Okay, processor to connect to, we would just say this. Undo manager, we're not going to use an undo manager, so we're going to use this cool C++ thing called Null Pointer. We need to give it some kind of identifier. So I'm going to call this parameters, which is what I always call it. And parameter layout, that's another thing we need. So parameter layout is this right here. Let's go put that. This one can be private, it doesn't matter. So this is a parameter layout. It's called, create parameter layout. But what do we need to pass in? Oh yeah, just create parameter layout. Oh, and I forgot this needs to be dereferenced. Yeah, so we pass this create parameter layout into there, and now the tree state is constructed. But now that we have this create parameter layout, we're gonna have another issue because it's not implemented, I think. Right. So undefined. Oh, you get this weird linker error. Yeah, so that's not super helpful all the time. Create parameter layout. That just means that we haven't implemented it. So we need to actually implement it. And let me go ahead and pull it from here. And it doesn't matter where you put it, but I like putting it at the top. I don't even really know why, but yeah. So the one thing about copying and pasting from other projects is the other project's class name is going to be there. So you need to copy and paste the current project into it. And I'm going to delete all of this except for one. Input. Okay. And we don't need that. Okay. So this is the parameter layout, and this is kind of the container for our parameters, our automatable parameters. So the first thing we do is make a vector, which is just a data, what's the word? So we make a vector, which is a data structure. It's kind of like a array in other languages, but a vector, you can change the size dynamically, and it's cool. So yeah, we make a vector of type ranged audio parameters, which is just the audio parameters. We're calling it params. And every time we make a new parameter, we have to push it into this vector. And that's what this is right here. This is what this is right here. Params.pushback. And then we add the parameter in there. And then this method just returns those parameters. And then this is how we actually create a new parameter. We can say auto, which will make it the type that it needs to be. We'll call it whatever we want. What are we doing right now? We're doing volume. So let's just say gain. I'm going to call it gain. So now I need to take it and put it into this right here, because this is where we're pushing it into this params vector. So we need to make sure that the names are the same. So we are using make unique pointer, which is a smart pointer in C++. Basically, what this type of smart pointer does, I believe that whenever it goes out of scope of whatever it's being used for, it gets deleted without you having to do it, which is really cool, because the other way to do this would be to make a raw pointer, but then you'd have to manage the memory and you'd have to remember where it needs to be alive and all that nonsense. So, smart pointers are the way to go. There's really not a lot of reasons to use raw pointers with all these new C++ features. So yeah, so we're making basically a audio parameter, and there's a couple of different things you could do. There's audio parameter float, int, bool, and choice. So audio parameter, actually, let me not skip ahead. I was going to explain what each one looks like, but let's do this first. So each audio parameter, you have to give it an ID and a name. The ID is what the JUCE project will use to reference to it. So I'll just call it gain. And the name is what you'll see come up in the DAW as the parameter's name in the automation data. So I usually you just make it the same word, but with a capital letter. That's a pretty good way to do it. And then this is the range. So the starting value, the ending value, and or not starting, but the lowest value, the highest value, and this is the starting value, wherever you want it to start. So this is gain. So let's make it -24 to 24. And then let's make it start at 0 so that it's always in the middle. And that is it. we have a parameter that we can call other places in the plugin with this gain word right here, which is cool, which means that in here, we could do this. Instead of saying 4, we could say, we can get the parameter from the tree state. So we have to dereference tree state. And this is a lot, and we'll simplify it in a second. And then the way you get it is get raw. I knew that was coming. Let me, I'm gonna want to redo that so that that's not whenever I go record it and cut it up into clips. So we're gonna multiply, instead of by 4, we're gonna multiply by what is in the tree state. So we can say tree state dot get raw parameter value, and we pass it in what we want, which is gain. Cool, and that would work. So now whatever the value is, it's being multiplied by that. But this is pretty ugly, right? If you need to write it in other places, this isn't really helpful. So we can just make a variable up here, like let's just say float gain, and then we can set it equal to this. Or let's call it raw. Let's call it dB gain, because this is negative 24 to 24, which is dB, right? Which brings me to my next point. We could do this. We could take this dB gain and we can multiply it by our signal. But this is negative 24 to 24, right? We need to, that's not what it actually wants. We need to change it to a logarithmic gain value. So what we're gonna need to do is multiply it by something that's between 0 and greater than 1, right? So if you multiply the signal by something greater than 1, the signal goes up. If you multiply the signal by something between 1 and 0, the signal goes down. And if you multiply it by something negative, you're not gonna have a good time. So dB has negative values, so we need to change this into a gain. So we can do another variable right here. We can call it raw gain, which is the actual kind of 0 to whatever log value. We can set that equal to this really handy JUCE method called dB to gain. Now, if we didn't have a JUCE method, we could use a PAL function. And the conversion from dB to gain is 10 raised to your gain divided by 20, and that's how you would get to gain. So that's kind of that's not the code way to do it. The code way to do it would be to use a PAL function, a C++ PAL function. So what this is doing is it's multiplying the first argument, not multiplying, sorry. So it's taking the first argument and raising it to the second argument. So right here, we would put dB gain divided by 20. And right here, raw gain, and that would work. Cool. So this is the conversion. Now, this is kind of annoying to have to write all the time. And it's also not super clear what's going on. So there's actually a better way. JUCE implemented a version of this. I'm not sure what it does under the hood. There might be some extra stuff, but there is a decibel to gain conversion in JUCE, and it's inside of the decibels class. So we got decibels, and then it's got dB to, or decibels to gain. And then you type in your dB gain, and it will convert it to raw gain, and that will work. So that's all set up. That works fine. But we still don't have a slider or anything to actually interact with this. And like I said, one way to do this would be to actually go to the editor, make a slider connected to the tree state with a attachment and all kind of nonsense, but we're not gonna worry about that in this video because we're gonna just kind of rely on audio. So there's this really awesome thing that I had no idea existed until the audio programmer made a quick tutorial about it. Right here in this method, this is how, sorry, let me do this. Let me build the plugin. Now this GUI, the window that you see for your plugin is called the editor. And this pops up and exists because of this function saying return new project name audio processor editor. Now what you could do is instead of returning that, you could return what's called a generic one, generic audio processor editor, and pass it the same this argument. And what this will do is it'll create a generic editor that is based on what you have in your parameter layout. So watch this. We have one float parameter called gain, and when I build this, look at that, a slider called gain comes up and you can interact with it. And this is what sorry. So this is a basic slider that you can use to interact with it. You can't change the way this looks or anything, and as you add other things, it'll just kind of plop it down below, and the plugin window will get bigger and bigger as you add more things. But it's a million times faster than going into the editor and creating a UI, especially when you're just prototyping DSP or prototyping a project for somebody. It saves you just a massive amount of time. And what we could see is I'll do not standalone so that it actually builds it in the plugin version, and we'll open it in Logic and we'll check it out. Okay, that was quick. Okay, let me turn the beat off. Okay. Okay, so now we've got our window, the same generic parameter window. So let's check it out. Oh, look at that. I mean, look how fast that was. All I did was, so making these parameters takes time, but this is something you have to do anyway to have automatable parameters. So by simply changing this to return a new generic audio processor editor, now we have a UI that's going to build itself every time we make a new parameter. And check this out, we can automate this since we have, I'll show you, since we have the tree state and the parameters. Look at that stream, and look, we have our gain parameter. And check this out. Look at that. Automation works. It works perfectly. I mean, it was super quick. I mean, look how easy that was. Like if I wanted to go in and create a simple UI, like if I even just wanted to remake this UI to make it look the exact same, even though this is kind of the default setup of a slider, it would still take maybe like 10 minutes or something to make this. And then if you're just starting out, it might take even longer because you might not be aware of some of the kind of quirks of UI and setting up a JUCE UI. So there might be some things that I think are quick to set up that actually aren't for a new person. So it might actually take you like half an hour or something to just make this. So making this or returning this generic audio processor editor is just amazing. Like it's just awesome. So yeah, I mean, that's it. So let's close that. The only thing that we haven't done is if I save, it's not going to save the, like, let's say I move this. and I hit save, it's not gonna, when I reopen the project, it's not gonna save it because we haven't done that yet, but that's not super important yet. Let me show you what some other things look like. So let's make another one. Let's make one called phase. Oh, and by the way, the reason I'm putting P in front of these is just because it's called, to me, they're parameters. So I'm just saying, you know, P for parameter. So equal std make unique. Oh, one thing I want to mention, something I was unclear of when I was starting, is differentiating between what's a JUCE thing, what's a C++ thing. So whenever you see std::, that's the C++ standard template library. So that's going to be a C++ thing. And then obviously if it's prefixed with this JUCE namespace, it's going to be a JUCE thing. So C++ doesn't have audio parameter float, but it has make unique pointer. So make unique, the class that we are making the pointer of, which is an audio parameter float. And then, oh, sorry. No, this is phase. So the whole point is I wanted to make a bool. So we can do bool. And we pass it the same thing. Let's see. It'll be phase. So let's say phase. And then for bool, the other argument is the default state. So I'll say false. And then we need to push it back into this params vector, this little data structure. Cool. So that's in there. Let me clean this up a bit. Oh, my beat was off. So I just added something called phase in there. So we should be able to build and see what it does. Look at that, a little checkbox. So that's what the bool does. Whenever you make an audio parameter bool, it'll give you this toggle box, which is something you could set up in the editor. But like I said, this is a million times faster. So let's actually do something with the phase. Another super amazing big brain DSP concept I'm going to do is let's flip the phase of the signal. So what we need to do, let's visualize this a little bit. Let's go to Desmos Calculator. Let's see, I'm gonna say, let's plot a sine wave, sine of X, and then let's plot another one. The cool thing about Desmos is when you plot multiple things, that'll make them different colors for you. X. And then we can, so you can see that there's a blue one and a red one, and we can actually visualize that by just adding 2 to that one so you can see that they're on top of each other. So let's pretend that they're, you know, at the same spot just to visualize it. We want to invert the signal, okay? So we want at every point on the sine wave to be the opposite or the inverted point on the original wave. So for example, whenever X is 1, we want it to equal -1. When X is, I don't know, where's 0.5? Somewhere right here, 0.5, we want it to equal -0.5 so that the phase flips. So the easiest way to do that is to multiply it by -1. Check that out. So you can see that we've multiplied the wave by -1 and we've completely flipped the polarity of it. So at every point on the blue line, or let me say it like this, at every X value on the blue line at the same X value on the red line, their combination should equal 0. So at 1, it should be 1 on blue and -1 on red. At 0.5-ish on blue, it should be -0.5-ish on red. And you can take that logic and extend it all the way throughout both waves. And at every point at both waves, their combination should equal 0. Meaning if we flip the phase of the signal in JUCE, we should be able to make another track without the plugin, and it will have the flipped phase, so they should cancel each other out. So let's see if that works. We've got raw gain. Oh, right. Okay. So right now, the phase toggle is a bool, right? Which means true or false. So what we're going to want to do is, if phase is true, if it's on, we want to flip the phase. And if phase is false, if it's off, we want to not flip the phase. So we can do that pretty easily with an if statement. So let's just do that. Let's get some kind of variable from the tree state. So let's say tree state dot get raw parameter value, and this is going to be phase, I believe we called it. Cool. So let's do an if statement. If phase is true, we want to flip the phase. So to flip the phase, we just multiply it by -1. And then if phase is not true, if it's false, we're just going to do our processing without the phase flip. Now, this is perfectly fine, this if-else statement, but we could talk about this in the future, but you really want to avoid if-else statements as much as you can in your DSP if possible. It doesn't matter right now, especially for something this simple, but yeah, it's just something I thought I should mention, and we could talk about that in the future. But yeah, so if phase is on, we are flipping the phase, and if phase is off, we are not. So let's build that. Oh wait, we're in standalone. Let's go to AU, build. Okay, I'm gonna turn off automation. Okay. So let me make a duplicate track with the same and let's ignore our plugin for a second. Okay, so we should have 2 signals playing. Whatever. So let's use Logic's gain plugin. And let's see. I don't want to turn the volume down. I just want to flip the phase. So let's flip the phase. Hit play. Look at that. Silence. Because the phase is flipped on one signal. So we know that works. Or I should say, we know flipping the phase does something. I'm not just lying to you. So we're back to no plugin. So let's put ours on and see if it does the same thing. Okay, we have our plugin. Big brain. Cool. The phase is being flipped. And something I didn't even think about. Instead of doing audio, let's see, I am gonna mute this track and let's use a test tone, like a test oscillator. Let's go to utility, that sine wave at 220. Okay, and let's also get an oscilloscope. Okay, pull our plugin up. Let's flip the phase and check it out. Oh wait. Yeah, okay, no, that's not gonna work. That's actually not gonna work because I assume that this oscilloscope plugin is whenever anything changes, like the phase or something, it's probably gonna display it the same way. So never mind, I'm not gonna show that. The best way is this graphing calculator, because this is not gonna do any kind of you know, extra processing to make it look normal to you. I should have known that wouldn't work. I just didn't think about it. Cool. So that works. The phase works. And that's pretty much it. Let's check out the other audio parameter. Now, I don't think we're going to have it actually do anything because I can't think of anything to do with it yet. But there is another one called choice. So let's do std make unique JUCE audio parameter choice. Okay, I don't know why I didn't. Yeah, whatever. Choice. Okay, so choice. Oh yeah, okay. So choice uses the same kind of thing. So we've got choice. Oh, I need quotes. And then it takes in a string array as your choices, and that's a JUCE thing. So to do that, we could say JUCE string array choices is equal to, and then we could just make some random things that don't even, or let's say this. Let's pretend that this is some kind of plugin module. So let's say like some kind of rack thing. So let's say compressor. Let's say EQ, and then I don't know, reverb. So we pass in choices here, and then you also pass in what choice you want to default to. So the first one would be 0. So I'll just do that. And then we have to add this to the vector. Let's clean up I have no idea why that always happens right here. That, and let's build it. We're going to do it in standalone. Just press play. Cool. Check that out. Here's choice. It makes a little drop down menu thing. And we can see the choices: compressor, EQ, reverb. Cool. Yeah. Okay, so I don't really have an example of something that we can actually do with those yet, in terms of DSP. But there is one more thing that we can do to make our DSP a little better. Now, like I said, this process block is the process block is running sample rate divided by buffer size times per second. So, you know, a bunch of times per second. And you can see that we are setting or we are getting the variable that we want from the value tree every single process block, or every single time it's processing, which we only really need to get it when we move the slider, right? We don't need to actually get it every frame or whatever. So what we can do is there's actually a method called parameter changed, where every time you change a parameter, you can do something, you can put some code into a method. So instead of calling this, you know, 344 times a second when you only might need it one time a second, or maybe even one time every couple of seconds, we can move these out of here and we can put it in a different method. So this one is called parameter changed. So what this is going to do, parameter changed, it takes in a parameter ID, which is this ID right here that we set up at the top. This is the ID right here. And then it takes in a new value, which is the actual value being changed by the slider or whatever. So we can implement that. Let me go pull it from here. Let's go ahead and just put it right under it. And let's make sure we have the correct class name. We also need our curly braces. And one more thing that we actually need, because if we build, you might think, okay, we have the definition right here and we just implemented it, so it will build and it will be all fine and dandy. But in fact, it will not. Only virtual member functions can be marked override. I've marked it override, but it works in this project. Isn't that so strange? So what's actually happening is there's another thing that we actually have to implement for this to work. And if we go to the docs and we go to parameter changed, this is the kind of stuff that's really hard when you're starting off, because reading the documentation is difficult in and of itself. But then it's not always immediately obvious, especially as somebody new to C++ and new to programming in general, what to do. So audio processor value tree state listener. Oh wait, hold up. Let me go to parameter changed. So we go to parameter changed and we see this other thing called listener. If we scroll to the top, we see parameter changed and we see listener. Wait, is this really the correct page? Ah, this is the correct page. Okay, so audio processor value tree state. It has, let's see, is set parameter, or is parameter changed in here? I don't remember. Yeah, anyway, if we go back to the page we're on, we see this listener, and this is what it actually needs to actually work. So if we go to this callback method is called by blah, 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 when parameter changes. Let's see. Interesting. I don't see exactly where it explicitly says that you need the listener, but we do see this destructor for a listener. So that's what we actually I might be on the wrong part of the docs, but it's still kind of unclear if you don't know anything about C++ or programming, what you need, but you need this listener. Because if you go to like oversampler, you know, we see we can create an oversampling object and we can pass it in this, and then we can call any of these functions. And the audio processor value tree state, as we were on the other page, kind of looks the same. Like we have parameter change. It's just a method. We should be able to call it, but we have to implement it because of this equals 0. It's a virtual method. And then it also needs this listener. So let's create this listener. You create it at the top right here. What we actually need to do, this is the plugin processor class definition. And it is inheriting, this little colon means that this class is inheriting from this class. So this is audio processor. So we need to inherit from another class, which is listener. So we can just put a comma and we can do, wait, is it parameter listener? What is it called? Audio processor value tree state. Okay, so we need to, let's see, we need to also inherit from JUCE audio processor value tree state, and in that class and or namespace, I'm not sure which one it is, it has a listener. And that's this is one of those things that, you know, if you're starting out with C++ and you're starting out with JUCE, I mean, it's not reading the docs, it isn't obvious at all. It doesn't say, hey, you need to inherit from audio processor value tree state listener, or, you know, maybe it does, but it's in such a big brain way that, you know, I did, when I was starting out, I had no idea. And then, you know, when you're starting out, it's just difficult. But yeah, this is what you need to do. So anytime that you are trying to use a class, a JUCE class, and you see equals 0, that means you have to implement it yourself, which is what we did here, right? We actually wrote the definition and the implementation in the project instead of just we're not just calling parameter change. Like we're not saying like thing dot parameter changed. We're actually implementing the function, and that's because it is a virtual method, and you can tell if you need to implement it by this equals 0, which there's a lot of things that you do in JUCE that do the same thing. But we also needed this, which is not always the case. There are some overrides that you would implement that don't need something like this. So yeah, it can be difficult, but this is a really big one. This is one you'll use all the time. So if you know how to use this one, you'll be set for a lot of stuff. So that's fine. So basically this parameter changed is going to be called anytime this listener, which is listening for changes, anytime this listener hears a change, it will call parameter changed, and then whatever is in here, it will, it'll do something. So how do we actually get the listener to listen to things? We have to actually add each of these parameters as a listener. So we can do this in this part of the constructor right here. We can say, let me just grab it from this project right here. Right, so tree state add listener. This, okay, so tree state, which is our, our tree state, our value audio processor value tree state, and then we can add a listener. Add parameter listener. Which parameter we want? So let's start with gain. And then it's going to be this. And then we have to just do that for the next one, which is phase. And if you don't do this, you'll move the dials and nothing would happen. So if you ever add, I do this all the time where while I'm prototyping, I'll add a parameter, and I won't do this in the process block. I'll put this in the parameter changed method, which we're going to do in a second, but I always forget to add the listener. So I'll be changing the slider and it won't be doing anything, and I'll just assume it's a DSP problem, but I just forgot to put the listener. And then in the destructor right here, we need to remove the listener, because if we don't, I think that'll probably be a memory leak. Remove parameter listener, and let's see, gain, and this just this is the class that we're currently in, so this class right here, and let's do the same thing. Phase, cool, and now we can implement the logic in parameter change. So the difference is the process block, like I said, is going to be called 300 times a second or whatever it is. And we don't need to do this logic 300 times a second, because most of the time we only need it to happen when the slider or whatever changes. So we're wasting a whole lot of CPU and memory by setting these a million times. So what we'll do is we can check for each parameter ID, which is these. So what we want to do is say, if the current changed parameter that the listener is listening for is gain, do this. If it's phase, do this. So if parameter ID is equal to gain, we're going to do something. And if parameter ID is equal to phase, we're going to do something else. And since this function only gets called while you move the slider or something, it's not a big deal if you have bloated, inefficient code, really. I mean, there are going to be people who argue with me, but at this level, what does it matter? The weird thing, though, is that you can see, since we took everything out of the process block, this is all broken. So we're gonna need phase, and we're gonna need raw gain. So the best thing to do would actually be to make a variable in the class. So let's do this. Let's do float raw gain, and equal 1 by default. Because if the decibel level is 0, the gain level is 1, because if you multiply it by 1, nothing happens, which is a decibel level of 0. And we'll also have a bool phase equal false. And that should fix these issues right here. Wait, what? Oh, okay, build succeeded. Xcode does this weird thing where sometimes it takes a long time for the errors to disappear. So you can see it built successfully because we have made these variables, but they're not actually being written to yet. So we need to actually do that up here. So what we need to do is in gain, do the same thing. We'll say, what is it? Raw gain is equal to JUCE decibels to gain. And what do we pass in here? What we did in the process block was that pointer tree state dot get raw parameter blah blah blah. But what we have here is we have this called new value, and what new value is whatever the listener is listening to and currently hears a change, that will be this parameter ID. So at that instant in time, whatever is being changed, new value is going to equal whatever that change is on the slider or whatever it is. So if the change is gain, new value is whatever the number is coming from that that slider or whatever. And we can do the same thing. Phase is equal to new value, and that should be good enough. And we can check this with a simple debug statement, which is a cool JUCE thing. So it's just a way to log stuff to the console in debug mode. So it's just capital DBG. And let's log new value so that we can see it in real time. So let's do it for that. Let's also do it for phase, and we'll build in standalone so that we can see this debug stuff. Oh, and there's something even better. Hold on. We're gonna debug gain is blah blah blah, and then we're gonna say phase is blah blah blah. When you put multiple things in this debug statement, you'll want to put these two less than signs in front of it. And yeah, so let's build that. So this is the console down here. So let's open that up a little bit. Okay, so I'm gonna move. Oh, sorry. I'm dying. Okay, so I'm gonna move the gain slider, and we should see gain is whatever the slider is set to. So this is good. The listener is listening to each of these parameters, and whenever the listener hears a change, so right now the change is in gain, so that means the current parameter ID, because that's the one that's changing, is gain, and it's calling this function whenever that change is that parameter ID. So we can see that since that gain message is being printed out, this is also working. And then if I flip the phase, you can see now it's the phase. And it's saying 0, 1. It's not going to say true or false because the console is just going to, you know, convert 0, 1. But it's working. It's the same thing. So that's much better because now this logic is only being called whenever it needs to. So originally this was being called, you know, in the process block, so it was being called 300 times a second, which it doesn't need to because we're not changing the slider 300 times a second. So this is going to save on some CPU. This is a much better way to do this. And yeah, so let's build that and make sure it works. Okay, built. Open up Logic. Okay. Get rid of that. I don't want to see that. Here is our plugin. I'm gonna turn off the beat and let's make sure this still works. Cool. Okay. It works. Now there's really only one more thing we need to do, and we have a fully featured plugin. Is we need the changes to be saved whenever we close, whenever we save in the project and then reopen. And that's actually pretty simple. So in Git State, we have this will be called whenever you hit save, and then set state will be called whenever you start the plugin up. So couple things. Let's do this. We want to make sure that the plugin initializes to our default value. So the default value for gain is 0. The default value for phase is false. So in the prepare function, I like to do this. It's not necessary, but it makes me feel better. Is I will say phase is equal to whatever the tree state has right now. .get raw parameter phase, and raw gain is going to equal JUCE decibel to gain, and then we'll put another tree state call right here, and this will be gain. Okay, so now when the plugin starts up for the first time, oh right, okay, this needs to be converted to a float. Okay, right. So we can cast this from whatever it is right now to a float. So we can do a static cast to type float, and then whatever the thing is we want to cast to that float value, which is this tree state call right here. So we can do that. That should be fine. This is the same as if you just wrote the word float in front of it, but you know, it's a cool C++ cast. I'm not going to act like I know exactly what happens under the hood with static cast. I forgot, but yeah, I use it all the time. Yeah, so now the prepare to play is going to call this the first time the plugin starts up. And then what we need to do is go into Git State. And it's pretty simple. I'm going to pull it from this other project. Git State, where are you? Oh, I didn't do it in that project. Hold on, let's pull it from our actual project. This one. Here. Okay. Here we go, this stuff. Save params. Okay, here we go. All right, so what we're gonna do is just 2 lines of code. So we're gonna make a JUCE memory output stream, and we're gonna pass it in destination data, which is the data pulled in from the host, the DAW, whatever. And then we're gonna write our tree state to that stream so that the stream has all of our tree state stuff in it. So we kind of need to do the opposite in set state. Set state is whenever we open the plugin and need to initialize whatever the saved parameters were. So it is going to be kind of similar. So recall yeah, that's right. Cool. So we're going to say, we're going to recall the parameters, and we're going to say a variable tree is equal to the value tree read from data, and data is going to be whatever is in, in our memory stream. And then right here, I just do this check to make sure that the tree is valid, because it is possible that the tree could be invalid for some reason. It's happened to me before. If you have 2 versions of the same plugin, you're making changes to one, you're trying to open the other, it'll do weird stuff. But it is a good idea to go ahead and just check if your tree is valid. And then inside of here, all you have to do is just do the same thing you did here. So we're going to copy this and put it in here. Now, this isn't necessary. You could leave all of this out and just leave stuff in the prepare to play, and it should recall it. But I ran into a weird issue with a plugin only once, where for some reason, getting it in prepare to play wasn't actually initializing it because set state was being called first, and prepare to play, I had some kind of logic that was, I don't even know, it was relying on the order to be called in a certain way. So now I just put it in both so that, don't have this issue. So this is pretty simple. We're not having to make an XML file. We're just making a memory stream, writing the tree to that memory stream, and then we're pulling in that memory stream back whenever set state happens. Yeah. So let's build that and see if it works. Okay. Okay, so we know that by default the plugin starts the slider at 0 and then phase at false. So let's turn this down to something less than 0 and then turn that on. We'll hit save. We'll close the project, and then we'll open it up again and see if it's saved. Oh, you know what? I know what happened. This was a bad project to use. Something that actually... Something that I have that's actually in production. Okay, BT Clipper. That should work. Actually, I'm gonna go to something older. Let's see. Where's LVA? Let's see. That juicer. Obviously, I'm gonna cut this together and make it look like I didn't make a mistake on the video. So, let's see. I knew something looked funny. What is? Oh my god, what is all this? Wait. Oh, this is what I forgot. I forgot to actually set the tree state.state is equal to tree, this thing that we put in right here. So I think what was happening was this still existed in the memory stream, but we weren't creating a tree, or we weren't setting the state of our value tree in the project to what was saved. Yeah, that's what it was. Okay, now let's do it. Oh, look at that. Because I want to make a new instance, so I'm going to do that, hit save, close, open it, and do it again. So let's make an instance. Stream intro, blah, blah, blah. We'll turn it down right here, and we'll turn that on. We'll close it. Let's make sure it saves it while it's open. Close the project, and look at that. Boom. Okay, so we have a UI that dynamically puts objects as you put audio parameters. It's saving and recalling on close. It's automatable. We can automate it, and it's doing audio processing. I mean, this, besides making a nicer UI, this is a fully featured plugin that has everything anybody would expect a plugin to have. I mean, it does audio processing. You can automate. It saves the state. I mean, this is all you need. This is all you need to get started to make plugins, and it's fully featured. It's all there. We'll go over making a nice UI is a huge topic. I mean, that'll be across a bunch of different videos, but yeah. Let me get my thumbnail. Whatever. And there we go. A fully featured plugin. We've got a basic rundown of how everything works, and you can use the same setup to make a plugin. this repo is public. So let's see. So you can go in and clone this repo and make changes, or you can make your own project and you can kind of follow this this code and it should work for you. Yep, the GUI takes forever, which is why I have the Viator DSP library that you can go download, and it has a bunch of pre-made GUI objects that look really nice. Just to give you an example, let's go to GitHub and Viator DSP, and these are what my GUI objects look like. This is my fader, my dial. This is my menu right here. That's the what's it called? Combo box. This is the toggle, and it has a bunch of different stuff in it. Like I have a border, a cool looking border, fader, a label, menu, a number box, push button, toggle button, all made by overriding the look and feel with this style sheet. So you can go and download that, and it'll be some really cool, looking objects. But yeah, basically all we did in this 2 hours is the complete audio side of a plugin, and it's all fully featured and it works for you. So yeah, I hope you enjoyed that, found it useful. I hope that this helps people on YouTube make their own stuff. I'm gonna cut this into a couple of different videos to make like a maybe a 3 or 4 part series on DSP and JUCE getting started. So yeah, I'm gonna turn this into a couple videos and release them gradually so that I have content, because I've been lazy and I've only been doing the streams, which I don't even think the streams have been that useful to people, because I'm just working on my own projects, which might be like way more advanced compared to what people are trying to do and use. So yeah, I wanted to make this as simple as possible. Yeah, so cool. I actually didn't think that I was going to be able to do that in the 2 hours, but yeah, it worked out, and I'm going to turn this into a couple videos. So yeah, check out my other streams. I'm going to keep doing tutorial-based stuff like this. I think it'll be really helpful for people. I'm not sure what the next thing is going to do. Maybe start using some UI elements and do like audio parameter attachments. But yeah, thanks for watching. Feel free to be active in the Discord and do some stuff in Discord. I'd love to answer any questions, help you out with anything. And yeah, I'll be back Monday, same time, 5:30 Central Standard. Thanks for watching, y'all. See you next time.